So this is the questions related to AC specifically. So first one, peak voltage supply is 311 volts, so voltage peak 311. We're asked for the RMS, so remember the RMS is going to be less than the peak, so the formula from your tables or just using your factor is that. So it's 311 over root 2. You could leave it like that, but that is a bit ugly, to be fair. So you should really work it out. And you're getting 219.91, effectively 220, but we'll stick to our rule of 2 decimal places. Okay, all right, that's all there is. Next one is just the other way around. The RMS current is 60 amps. Calculate the peak current. Okay, so the peak current, we can use the formula if we like. Sorry, IRMS is equal to I peak over root 2. Okay, and it's 60 over, so IRMS is 60 equals I peak over root 2. So what you're effectively doing here is just multiplying by root 2, isn't it? So we're getting a value of 84.85 amps. And you always check to see, have I done the right thing? Have I multiplied or divided? The peak should be greater than the RMS. It is. You're in business. You've used root 2, you're in business. Now, what's important here, and what I didn't allude to a minute ago, is that if you're using RMS voltage and RMS currents, you can apply all your usual laws. You can apply Ohm's law, Joule's law, no problem. Okay, but it's only if you're using RMS values. So in this case here, we're given a peak voltage of 7.07. Once we change that to an RMS voltage, you're back to current electricity, DC. Effectively, it's the same as DC. So first thing here, okay, so we're given the peak. Okay, we'll write down our list. So we're given the peak 7.07. Okay, sorry, I have to put in the circuit. Sorry, let's get it right. Alternating current, and we're going to have a 3 ohm resistor, and we're going to have a 5 ohm resistor. So this will be part of the question. Okay, that's part of the question. So that's part of the question, right? So effectively here, you have the peak voltage 7.07, and you're asked for the average current flowing. Okay, so the average current flowing, straight away you're doing a circuit question. You say, okay, I have to use RMS values. So your first job is to get the RMS values. So V RMS, V peak over root 2, 7.07 divided by root 2. So So 4.999, as I planned, it's 5 volts. Okay, so that's 5 volts. So now we ignore the peak, that's gone, and we have a 5 volt supply. So our voltage, our total voltage is 5. You're asked for the current flowing in the circuit, which is the total current. So remember, you have to get the total resistance. So I'll do it down here. So it's 8 ohms. Okay, so the total resistance is 8 ohms. So to get the total current, well, it's just the total voltage divided by the total resistance. Remember, we're applying Ohm's law to the whole circuit. So we're getting 5 over 8, so 5/8. Okay, I should know what 5 over 8 is as a fraction, but I don't. So 0.625, yeah, I should have known that, 0.625 amps. Okay, so it looked dodgy with the peak voltage, but all you do is change peak to RMS and your business. So it's back to one extra step and the question is fine. Now the last part, the power generated in the 3 ohms, in the 3 ohm, that should be resistor. The power generated in the 3 ohm resistor. Okay, so we're just interested in this now here. So remember, power generated in a resistor, so what you've been given, you have the current flowing in the resistor, and you have the resistance of the resistor. So we have 3 formula, remember, for power, so which aren't on your tables, but I told you to learn them. Okay, and this one is obviously the I squared R one. P is I squared R, and we talk about I squared R heat losses a lot in here. So it's 0.625 squared by 3. So we square that and multiply by 3. Okay, and we're getting a value of 1.17 in its power. So it's watts, isn't it? Watts. Okay, so that's interesting as well. Okay, so remember these, you have three formula. Okay, P is VI, well I put it down here, or the way P is VI is 1 power. Remember that's what we use when we're transferring power from one place to the other. P is I squared R, remember, is our heat losses one, but it's relevant here because it's I and R what we're given. And you have the third one, which we don't use that often, but it's good to have it. P is V squared over R. Okay, if I was you, I'd have them learned. I'd know them off the top of my head. Okay, a step-up transformer is designed to output 200 volts. Okay, so the voltage in the secondary, the output voltage is 200. The input voltage is 10, so the voltage in the primary is 10. 50 turns in the primary, and we're asked for how many turns in the secondary. So this is just a ratio. Okay, voltage over primary over voltage over secondary is number of turns in the primary over number of turns in the secondary. So if you want, you just put it in like this. It's probably the best way to do it to avoid making errors. So it's 10 over 200 is equal to 5 over n in the secondary, or the ratio. Okay, it's going to be pretty obvious. Okay, and you multiply that across if you want to do it. Okay, so it's 5 times 10 over 200. Okay. Sorry, what have I done? 5 times, is it right? 5 times 200 over 10, and it comes out to be 100. Okay, the dog's ear of that. Okay, obviously 10 over 200 is equal to 5 over 100 anyhow. And don't do what I just did there. Okay, and the sun just came out for us. Alright, that's it. Very good.